This is the same problem which we have done using Excel. Now I will explain how this problem can be solved quickly using SPSS software, because most of the research scholars are using SPSS. So now let's open SPSS. Now we have to type in data, because we are going to make a new file. So this is SPSS. Now there are two windows, one is data view, another is variable view. Our first variable is machine numeric, but if we want it to be a machine cannot be a numeric value, so we can have it a string of 8 characters. So now here I can type machine 1. See, we had in a matrix form, data was in matrix form, but here we want to have data in two columns representing two variables, because these two variables will be considered as one independent variable and the other as dependent variable. So machine 1, let's have M1. So we have now there are 4 set of values. It is very important in SPSS how you place the data before the analysis. So actually we are doing ANOVA analysis, we are not doing pairwise t-test between different machines. So if we were doing t-test, then we had to take the same table of the data. Every column could have represented machine type, but here, because we are going to perform ANOVA analysis, so we are going to have the data in this way. So first column, go to SPSS, paste over here. Now we can paste data for second column. Now we have these two columns. If we see in variable window, one is machine, the other is tensile strength. Now see here, go to analyze. If we want to see the spread of the data of the tensile strength, we can see descriptive statistics. Go to general linear model, go to univariate. Dependent variable is tensile strength. Pick here, machine is our fixed factor. On dependent variable, there is no random factor, there is no covariate. If I want to see the plot, machine versus tensile strength, I can see over here. Continue. If I want to do an analysis which is called as post hoc analysis, which gives us a difference between each machine, I can select one of that analysis. Suppose strength demand cools. Continue. I press OK. There is an output window visible to us, which gives us, oh, coming analysis is coming for data for machine 1, and it ensures that the data is correct. Now if we see the Anova table, first is interrupt set model, don't care about this. Machine, this is our variable machine, which gives a value of f 0.307. When we should remember that the value which we had calculated was 0.28 something. So it is very close to our calculation. We are fortunate that we have got the correct calculation using Excel. This was that, and now what we see the significance value, or p value we call it, as 0.9, which is far more than 0.05. So the calculated value is far less than the value of table value, a value at particular value of alpha 0.05. So this was what was the ANOVA analysis, from where we see that if this value would be less than 0.05, then only we could say that analysis machines have significant effect on tensile strength. But in this case not. In post hoc analysis post-hoc analysis, all machines shows a mean value which is almost similar, and not similar, then also the spread of the data will be very same, which we can see over here. This is the data, but it is not significantly different. We can change it and see how this difference is. We select this axis, we modify the axis, scale, first value, suppose I make it 0, and then I see how data is. See, data is quite flat in nature. So it means there is no significant change due to the change of the machine. That is what I wanted to say using SPSS, the same thing I did in Excel. If you want to save file, you can save as output, which will be SPB, and your input can be saved like this. You can save to the location wherever you wish for. Suppose my location is, you can save as SPSS. Same file I can export as Word file if I want to. The same location it is showing, so I can save as the Word file. So I have my data in my hand. There is another way of doing this. Open a new file. Suppose the data was here for 6 machines. I pick up all the data and I come back to SPSS, new file. I place this data over here, copy paste. I go to analyze, I go to general linear model, I go to repetitive measure. In repetitive measure, every row is a kind of replication and every column is a label of the independent variable. In our case, independent variable is machine labels are 6. I can add that. Sphericity is nothing but testing whether the data satisfying the assumptions for repetitive measure analysis. So I'm not going in more detail of not least test of sphericity, but what we see here is again the F value calculated is 0.291, slightly different than the other procedure, which also indicate that machine has no significant effect on the tensile strength of the rubber stamp. So this is also you can save as, or you can export this data to the same location as output. As output, I can refer as
maybe a quite lengthy lecture, but it was required because if I move on to other kind of analysis in forthcoming lectures or other kind of tests, then this basic understanding of ANOVA is important. That's why I took a little longer time this time and not the next time. Thank you very much. Don't forget to subscribe if you like it. Thanks.